at these, and how we should be using these is as follows. So the first problem is kind of the hardest version of what we've been doing with ratios. It has everything in it, has not nice numbers, okay? So we should be using that to review all aspects of the ratio types of problems that we've been studying. The second problem is about percents and just kind of clarifying when they use certain words what that really looks like when you do the calculation. You guys generally do them correct. It's just having the word grows in there means something a little bit different than what you might first think. So I want you to, one, make sure you can do these skills, but number two, also think about how they apply to your creature. So the reason we keep coming back to these ratios is because your creature is a three-dimensional figure, right? Which means it can change in length, but it can also change in areas of different surfaces of your creature, and it can also change in volume measurement. So I just want to, before we go through this, think about your guys' predictions for your creatures. When you guys looked at your own and other people's predictions, what does most people do to predict new measurements for their creature? What'd they do? Times it by 6 because of the grows up to 600%. And what kind of measurements were you guys timesing by 6 when we did that? Length, width, right? So not volume or area calculations, just length measurements. So out of context of this problem for a minute, but in the context of your creature, just, you don't have to write this down. This is just some info for you so that you can think about this as you get to the next part of your write-up. But you guys are basically saying that you think your creature length is changing by a factor of 1 to 6 when you multiplied by 6. Do you guys understand that? Okay. What would that mean about the ratio of the volume of your creature? What would it be? If you think the length is changing by a ratio of 1 to 6, if that was your prediction, what are you predicting about the volume? Not 36. Area would be 36. So you think the surfaces are changing 36 times. 1 to 216. And how is he getting the number 216? Cubing. Now, I want you guys to think about that for a minute. Okay? Let it sink in. When you say your length is multiplying by 6, you are saying the volume of your creature is growing by a factor of 216, as in you would think that when your experiment was done, your creature was 216 times its original size, as in building like a new three-dimensional creature with 216 of the original creatures I gave you. Now, a lot of your creatures have grown, and they have grown significantly. I just don't know if they've grown that significantly. Like if they grew that significantly, I feel like we wouldn't fit in here right now. Get what I'm saying? So the reason we're looking at these ratios is to understand our first inclination and predictions. When they say something grows, we tend to think one-dimensionally. And that's why we made this prediction. But our creature is not one dimension. It is actually three-dimensional. So they could have been talking about a whole different world of growth. Maybe they were talking about areas like the face area or whatever, the whole surface area. Maybe they were talking about volume, like thinking about our creature like a little prism or something. Maybe that's what they were talking about. So number one, kind of expand your mind as we move forward in our project about what growth really meant compared to your initial predictions. Do we change our initial predictions? No, because we're evaluating two things. Were they right? Which is why we need to learn the mathematics of how to calculate if they were right. But the second thing is, were they deceptive? And that is going to come from what people originally think versus what's really happening, and you're going to make that decision, okay? So just kind of side note about what your predictions were really saying there, okay? So though I think that some people's grew well, I don't think that in all areas it grew times 6, or we would see creatures that are three-dimensionally 216 times bigger than they were before, okay? All right, so let's talk about my example of my creature on here, okay? So I said that my creature had a volume that was 7 times larger after it grew. So there was an original creature, I put it in the water, it grew, and now its volume is 7 times larger. Okay? What piece of given information does that give me? A volume ratio. Okay, so I know that my volume ratio is 1 to 7. Okay, 7 times larger. Before I do anything else, okay, if we're struggling at all, the first thing we should do is just try to decipher what that means about the other ratios. If the volume's growing 7 times bigger, are the side lengths going to grow 7 times bigger? No, they're going to be a lot smaller than that in order for the cubing to be the 7, right? So remember that our volume is cubes, our areas are squares, but the things we're squaring or cubing come from the length ratio. So kind of the key to get all of the ratios is to know the length ratio, okay? And right now you don't know that. You know the volume ratio. How can you turn the volume ratio into the length ratio? Thomas? We can cube root it. So remember, this is literally saying we can let a cubed be 1 if we let b cubed be 7, as long as we keep those exact numbers, which means a would be 1 as long as b is the cube root of 7. Is that okay with everybody? And now that we've got it to an a and a b without a power, we have that length ratio. Okay, sorry, that's not a pretty cube root. So our length ratio is 1 to the cube root of 7. Just to give you some context, because we haven't been punching these in the calculator, the cube root of 8 is equal to 2. That means the cube root of 7 is a little bit less than 2. So if the volume of my creature gets 7 times bigger, each side didn't even quite double. It didn't even get quite multiplied by 2, multiplied by something just a little bit less than 2, the cube root of 7. Okay? All right, now how can I get the area ratio? Good, I can square, but specifically the length ratios, right? So I want to take 1 for A and square it, and I want to take cube root of 7 for B, and I want to square that. So 1 squared is just 1, and the cube root of 7 squared is the cube root of 7 times another cube root of 7. You can keep it like that with the squared notation, or you can call it the cube root of 49 if you don't like leaving the powers up there. Okay? So first up, questions about the ratios. So are we okay that we got the given one of volume and that we had to go to the lengths before we could get to the area ratio and what each of these look like? Right? Now let's go answer questions, because we know we have the keys here to answer them. It will just be a matter of how much work we have to do to get the answer. Okay? So first question asks for the ratio of the circumference. What category is that going to fall into? Circumference. Length. So we can measure with a tape measure. It is about measuring length. It's not about area or volume. So this first ratio is going to answer that question, and it literally asks for the ratio. So I don't have to do any extra work to answer this question. I just have to identify the right ratio from my chart. So I have to know that circumference is equivalent to a length type of measurement. Okay? The second question says, what factor was each side length multiplied by when the creature grew? So first, which category? Are we talking length, area, or volume? Length. Are you guys okay with why it's length? Because the word here was a side length. So that's just a length measurement, something I can measure with a tape measure. But this time it's not asking for the ratio. It's asking for the factor, or what was it multiplied by. So I know the ratio was 1 to the cube root of 7, but that's not the answer. The answer is, how did 1 turn into the cube root of 7 by either multiplication or division? So 1 multiplied by what mystery number made the cube root of 7? So like 1 times what makes cube root of 7? The cube root of 7, because you would just be dividing both sides by 1. This problem would be a lot more complicated if we didn't start with ones, right? We'd have to actually divide out that number and stuff like that. So this just ends up equaling the cube root of 7. So the answer to this problem is just that value. Is everybody okay with these two questions asked about the same ratio, but they asked the questions in different ways, which made you do a little more work in the second question, that you couldn't just write down the ratio. You had to identify how did 1 actually change into the cube root of 7, and that's by multiplying by the cube root of 7. Okay? All right, the last problem has a lot of extra work involved in it too. I think it's kind of the most complicated of the problems that they could ask you. So which category are we going to look at to answer question C? Which ratio are we going to use from our chart? Area. Because in question C, they specifically are talking about areas. So I know that I'm going to use this, but it does not say what is the ratio, so I don't just get to write down 1 to the cube root of 49. But I am using that. So remember, 1 to the cube root of 49. I know this and I get to use it. The question is, how do I use it? And remember what a ratio is. This is comparing the old area to the new area. Okay? So what do they want me to do in this problem? What am I actually supposed to come up with in part C? A new area. So not a ratio and not just a number from the ratio, but an actual new area. So I'm supposed to come up with some other new area. Based on what extra information did they give me? The old area, which is what? 5. So here's what I know. I know the area is supposed to go from 1 to the cube root of 49. And then they're asking me, well, if it's 5, what does it get turned into? So there's kind of two ways to do this. One way is if you really understood this part up here and that the ratio from 1 to cube root of 7 just means multiply by the cube root of 7, then when you look at this one and it says 1 to the cube root of 49, you might think that just means multiply by the cube root of 49, and that's what you'll do to 5 to get the new value. The other way is to take these two ratios, since they're talking about the same thing, and set them up as a proportion. Meaning I know 1 gets turned into the cube root of 49. That's supposed to be equal to 5 getting turned into something that I'm unaware of right now. And I'm going to figure out. And then I would cross multiply to solve these. So 1 times x is x, and 5 times the cube root of 49 is 5 times the cube root of 49. And that gives me the new volume, if that's the ratio, or the new area, sorry, if that's the ratio. Is that okay with everybody? Okay, and that's kind of the most difficult version. So I gave you one with not nice numbers. I gave you a volume of 1 to 7, so you had to deal with the radicals, okay? I tried to ask the question in every way that you would see it. What's the ratio? What is something being multiplied by? And if I give you a different number, can you tell me what the other actual number is? So it's kind of all categories and the most difficult situation that you would see. Is it all right with everybody for kind of review of the ratios? All right, so this is kind of the stuff that you're going to want to go back through and review before your quiz, since this is the new topic of today, or this week, right, for our quiz. All right, new topic of today is percentages, which you guys are actually a lot more comfortable with and something that's a lot more familiar to you. So let's hear the answers that you got. If your salary grew 50%, you're making $10 an hour, it grows 50%. What did you guys say your new salary would be? Sean? Good. Anybody get anything different? All right, what about part B? If your salary grows 400%, so you have $10 an hour and this time you get a 400% raise. Okay, so 50. Did anybody get anything different than 50? Nobody got 40. Thank you for your honesty. All right, see all those hands that went up? So let's talk about this. Is it 50 or is it 40? So the reason I put this on here is this is almost exactly like your creature statement. Your creature said grows up to 600%, and you guys took things and you decided to multiply them by 6, okay? So people took grows 400% and they took their $10 and they multiplied it by 4. That's where 40 is coming from. But if I use that logic and I go back to part A, meaning I'm just taking the beginning amount and multiplying it by the percent, what is 50% in decimal form? And that would equal $5. So if you got 15 here, but you got 40 here, you did two different things for the two different problems. In this one, you did 10 times 4 and you stopped and said the answer is 40. In this one, you did 10 times 0.5 and you got 5, but you didn't stop. What did you do with the 5? You added it back to 10 because you knew the answer was not 5, because you knew it should be more. So when you are getting something added to or something's growing, you have to do the original plus the extra percent. So even if you guys really did think that your creature grows times 6 for 600% growth, okay, number one, I'm hoping that we're kind of seeing that probably wasn't the case based on what we just talked about, okay? But number two, if you are really trying to say it grew 600%, what did you guys see most people do on their paper? Multiply by 6. That's like this right here, but this answer isn't actually 40. It's actually 50, because if you get a 400%, if your salary is going to grow 400%, you're going to get an extra 400% of what you were making. So 4 times 10 is 40. But you were already making 10. $40 is the amount that it's growing. So you get your original 10 plus the amount that it's growing for 40, which makes a grand total of 50. You guys totally do it in the first problem because you know the answer can't be lower. But then the minute we give you guys a big number, you guys don't do it because you feel like it should just be quick like that, okay? So if length was really supposed to grow 600%, what should you have done instead of just multiplied a measurement by 6 for your creature? Added it back to the original, meaning my creature was 10 centimeters. 600% of 10 is 60. But if it's growing 60 centimeters and it was already 10, its final measurement would be 70. Does that make sense to everybody? Okay, so 2 kind of ideas today. 3-dimensional growth is not the same as 1-dimensional growth. So our predictions were probably off. Number 2, you were so close to calculating percent growth rate. Just when they throw that word growth in there, that percentage is added on to the original. It's the extra piece you're getting in addition to what you already had. Is that okay with everybody? All right, so final one, and this is going to give us a little formula we can use if you're a person that really likes algebraic stuff. Yes? Okay, answer it. It is not $12 because you just read it wrong. You just read it wrong. It's not adding 20% to your $10 salary. It's saying what was your salary before this if your $10 salary was after your 20% raise. Okay, question, yes. Okay, so we had 8.33 or 8.34, I know that this table says, and it just depends on if you think money rounds up once you pass it or it rounds like normal. Did anybody get $8? Okay, so those of you that got $8, if I wanted to calculate if you did it right, I would have said, okay, my original amount is $8. You just gave me a 20% raise. 8 times 20% is $1.60, but if I add the 8 back to that, I would actually only be making $9.60 and not $10. Is that okay with everybody? That's because you guys took 20% of the 10, those of you that got 8, but the 10 is not the original. It's the ending. So you don't know that you're at 10 yet when they're giving you the raise. They're giving you a percentage of what you originally started with, not a percentage of your new amount. Okay, so I'm going to give you guys a formula that might help you if you like an algebraic approach. So if we are talking percent growth, okay, if you want to know the percentage that something grows, it basically is a formula that contains 2 parts. Number 1, you have to know how much growth or how much change there was. So the first thing you do is you take like your new creature size and you subtract the original size. Like if my creature is 16 centimeters and it used to be 10, I would do 16 minus 10 and I would know that it grew 6 centimeters. But then my question is, what is 6 as a percentage? And when we say as a percentage, in your mind, every time someone says percentage, you should think percentage of what? Like, what am I getting a percent of? Okay. If you make nothing and I tell you that I'll give you 60% more like of that you still have nothing. Like, that's not very helpful. Okay. So when someone says you get a percentage of what? And when we're comparing our creature's growth, we're always comparing the new size to the original. So you always want to calculate your percentage as how much it was of the original. So once you find out how much it changes, you divide it by the original. Okay, and how this would help you in this problem, if you like the algebraic approach, there's other ways. This group guessed and checked. Reese, did you guess and check or no?
No, I just did 10.
Okay, yeah, so he did 10 divided by 1.2. If you're like, how would you know to do 10 divided by 1.2? I might not know that either, but you'll see that's what we end up doing if we solve it this way. So in this problem, you had the percent growth. You know the person got 20% extra than what they got before. So our percent growth is 0.2. You know that the new salary is $10 an hour. And what you don't know is the original amount. So everywhere it says original, that's my unknown X. If I'm going to solve an equation like this, the first thing I would do is multiply both sides by X because I don't like that X is in the denominator. So I'm going to multiply both sides by X. And I'm going to have 0.2X equals 10 minus X. And then just like a normal equation that has x in multiple places, I want to gather all the x's on the same side, excuse me. When you add 1x with 0.2x, remember this is like a 1.0, so you're getting 1.2x equals 10. And then we're doing exactly what he did. We are dividing 10 by 1.2, and you get that x is equal to 8.3 going on forever. And then you guys could interpret that as $8.33. It is technically past $8.33, but I don't think normally people round up your salary unless you get like past the 5 mark, but either answer would be acceptable if you guys have support. Okay, so this is kind of the focus of today, that we really want to make sure we're comparing the new to the original when we calculate percent growth. And then I know we said add it back on, and you're looking here that there's like a subtraction sign, but you saw that when we solved it the other way, you ended up adding some pieces together, and that's where you're seeing that happen. So you guys are going to practice this with classwork, and I'm going to help